Hi, I'm Mr. Corso. Today we're going to talk about the relationship between mass and force. Let's take a closer look at forces and how mass affects the force needed to move an object or keep an object in motion. Forces, recall, are push or pull factors. So any push that is exerted on an object or any pull that is exerted on an object is what we call a force. Here we see a pushing factor taking place, therefore it's a force. Here we see a pulling factor taking place, therefore it is also a force. So they are two opposing types of forces. Force is represented using a vector, in which vectors have both magnitude and direction. Here's an example of a vector. Vector A is 20 newtons west. 20 newtons is the magnitude, west is the direction. So if I put up a second vector, vector B, and we want to know what is this vector representing, we have to find the magnitude and direction. Vector B is about half the length of vector A, and since vector A is 20 newtons, I'm going to say vector B is 10 newtons. It's also pointing in the opposite direction of vector A. If vector A is pointing west, vector B must be pointing east. Now that we understand a little bit about forces and how to describe them using vectors, let's talk about net force. Net force is the sum of all forces acting on an object. Very rarely is there only one force acting on an object. Here's an example in which we see a car, and we use vectors to represent the forces acting on this car. Notice there are two green arrows that say 10 newtons, and they're pointing to the east or right. But there's an opposing force of 7 newtons, that purple arrow, pointing to the left. To know our net force, we have to add the forces that are working together and subtract the forces that are working in the opposite direction. So because 10 newtons east plus 10 newtons east would be 20 newtons east, minus the 7 newtons to the west would give us a net force of 13 newtons. Here's an example in which we see net force in a pulling factor. We see 2 newtons pulling to the north, but 2 newtons also pointing to the south, canceling out that net force. 5 newtons pointing to the east, 1 newton pulling to the west, therefore our net force would be 4 newtons east. Which finally leads us into our question, how does mass affect a force? If an object's mass increases, the force needed to move that object also increases. If the object's mass decreases, the force needed to move that object also decreases. So here we see an image, and the man is pulling, and we're going to assume this man is pulling with the same amount of force. It's the same strength. However, the difference between A and B is the mass of the object. So if we ask ourselves, if both men are pulling with the same force, which box will move faster? Well, the box with less mass will move faster if we are using the same amount of force. Going back to our video clip here, right now, as this woman pushes the cart, she is exerting a pushing force to the left. At the moment the other woman hops in the cart, we have added mass. It becomes more difficult to push the cart and keep the cart in motion because the cart now has more mass. So one of two things will happen. The cart will slow down, or the woman will have to push with a greater amount of force to keep the motion constant.